resistance. Okay, so we know resistance is voltage over current, or resistance in terms of resistivity here, and we have our three formula for resistance. Okay, so we have resistance is R1 plus R2, and we looked at how we derived that. Resistance in parallel, and the Wheatstone bridge, okay, which is a special case, and this is Wheatstone bridge, and we should put in underneath this balance, because that formula only applies when the Wheatstone bridge is balanced. We have our two derivations that we've just looked at, okay, so we mark those as well. Okay, and we now have this page sorted. Any calculation can be done off this page, and we've the next lesson is on calculations involving particular circuits, as we see. Okay. Now, then we have our measure resistance. We can measure with an ohmmeter. Okay, don't worry about the fact that it's galvanometer and convection ohmmeter to measure resistance directly. We'll see that later in the in electromagnetism. Now, the Wheatstone bridge and the meter bridge, remember. Okay, so the Wheatstone bridge, right, so you have a power supply, and you have two resistors in series, but we draw them like this. That's just kind of the way we draw them. You don't have to draw them like this. You could draw them horizontally if you liked, and two more resistors down here like this. Okay. You come around to here, and in between here you have a galvanometer. Now remember, galvanometer just measures current, small current. Galvanometer, named after Galvani, okay, who you came across in your film, right? And R1, R2, R3, and R4. And if it's balanced, if the current going through the galvanometer is equal to 0, R1 over R2 is equal to R3 over R4. And if you know three of the resistances, you can find the fourth. But it's quite messy, because you need to have a whole lot of resistances. So the meter bridge solves that problem in that we turn the top two resistors into one length of resistance wires. It's a bit like what we do with the potentiometer, really. Okay, so this is your meter bridge. It's called a meter bridge because it's a meter long. Okay, and then we have a resistance here, which we'll say unknown, and we have a resistance here, which we'll say known. Back to here, and we have our galvanometer, and we have a sliding contact. And the sliding contact has its own name, so it's called the jockey. Presumably because it rides on the length of resistance wire. That's a jockey. Okay, it moves up and down, right? So effectively the formula as, so this then is L1, this is L2. We can change that ratio at will, and we end up with L1 over L2 is equal to R3 over R4. In this case, R3 is unknown, so that will be our unknown. R4 is known, and we can get R3. We look at calculations in the next lesson anyhow. Okay. Two types of resistor. So light dependent resistor resistance decreases when light energy falls in it, and thermistor resistance decreases when heat energy. Okay, so just be aware of those, and again we look at those in more detail tomorrow in the next lesson. Okay. Right. To complete the page at the top, sources BMF, the mains around 230 volts AC, simple cells. Okay, so your battery converts chemical energy to electrical energy. So your simple cell is a 1.5 volt cell. If you have a group of cells connected together, e.g. a 6 volt battery is 4 by 1.5 volt cells. Okay, it's called a battery. So a battery of cells. So really your little 1.5 volt battery, as you call it, should really be called a cell. Okay, so that there is a cell. Okay, it's a cell. Right, whereas, okay, That's your 9-volt battery, one of your 9-volt batteries. Now, if we took this apart, okay, I might get around to doing it at some stage, you will find inside in that there are 6 cells. 6 cells in it. Okay, so something to do if you have a battery run out, but be careful. Right, now. Right, so that's that. EMF depends on materials used in the cell. Okay, and then you have these, we'll come back to these later. Okay, so we just mark the 2 cross there. Right.